Okay, exercise 5.2, medians and altitudes of triangles. Let's have a quick look at the new vocabulary. Obviously the first one is the median. The median is a segment with the endpoints being a vertex of a triangle to the midpoint of the opposite side. In other words, it must go from one angle to the center of the opposite side. The centroid is obviously, even though it's centroid, don't think it's the center of the triangle. It's where the three medians, don't forget yesterday we were talking about three lines that intersect is the point of concurrency. Where these three lines meet inside a triangle, that's called the centroid. The altitude, we've done that before, that's the perpendicular height, remember. Make sure you remember that it is the perpendicular height. So that you can get the right measurement that you need for your question. So what's the difference between a centroid and the orthocenter? Well, the difference is purely and simply the orthocenter is where you particularly perpendicular to the opposite side. So when you've got perpendiculars to the opposite side, then and only then would the orthocenter be noted. And here's a quick definition of the special segments and points within a triangle. You obviously know about perpendicular bisector and angle bisector. The median, if you remember rightly, I said goes from an opposite angle to the center of the opposite side. The altitude must be perpendicular, so you look for the right angle. The circumcenter, which is what we did yesterday, and then the incenter, and now we've got the centroid of the circle, okay, where everything fits. And here's the orthocenter, and as you notice, each one of these lines must be at perpendicular. Okay, and here's one of those little gems, the medians, distances. If you look at AP, it's actually 2/3. So AP is 2/3. So in other words, it splits it down to 2/3 and 1/3, and that's the same for all three of them. The relationship is 2 to 1. A typical type of question. It tells you that the length of BE is 9. Q is the centroid. Find BQ and QE. Well, look at what you've got. For a start, you've got to split it down. So we want 2/3 of BE, which will give us 6, or we want 1/3 of BE, which will give you 3. You can either do 2/3, 1/3, or you know that if this is 6 and your whole length is 9, if you just subtract them, which is what they've done here in the equation, you will get to the 3. Okay, so here's example 2. What is it telling you? It tells you that PT is 2. You've got to find PK. So in other words, you need to find this when you know that this is 2. Well, there are two ways of doing it. Here is doing all the segment additions and all your algebra. But if you think about it, if 2 is equal to 1/3, what is equal to 2/3? Well, obviously, if 1/3 is 2, 2/3 must also be 4. So that's KP equals 4. So either way, it's entirely up to you whether you go 1/3, 2/3, or you do it the way that they're showing you on this side. Okay, typical questions now. So let's have a look at question number 1. It wants to know the length of PC. So this length here, when you are told that PF equals 6. Well, if PF equals 6, and that is equal to 1/3 of the distance, well, what does 2/3 equal? Well, if 1/3 is 6, then 2/3 must be 12, and that must be the distance that they want for PC. As per usual with the questions, what is it telling you here? It's telling you that the whole length is 15, so 3/3 equals 15. Okay, and you want the AP part. Well, the AP is 2/3. Well, if 3/3 is 15, 1/3 must be 5, so 2/3 must equal 10. Okay, so here is the sort of question that you get to find out where the point is. And if you notice, all three coordinates are in the first quadrant, so all we need to do is draw this section. So 3, 6 would approximately be here. Let's call that letter A. 5, 2 would be over here, and let's call that B. And 7, 10 will be over here. Let's call that C. Okay, we've got our triangle. Obviously, you need to do it more accurately than I'm doing this. But what do we need to find now? Well, first of all, we need to draw a line from A to the center. So you've got your coordinates. Okay, this is 7, 10, and this guy is 5, 2, and this one over here is 3, 6. So what you've got to do is the midpoint formula for this guy to make sure you get the center of that, and then you can draw your line down to here. Similarly for this, we need this length here, we need the midpoint of that, so we can draw that line through to that, and then obviously we need the midpoint of this section so we can join it through. Okay, when you've finished and you draw it accurately, I've obviously drawn it freehand, you should be able to see where that point is. Okay, so now we're looking at the altitudes, and don't forget your altitude must be perpendicular to the side. Okay, sometimes obviously like in the first one, if this is the first one, it's inside the triangle. If you've got an obtuse, it's going to be on the outside. So this is triangle number 2. Okay, questions that you get in like an example 4 where you've got to find the orthocenter. Don't forget, you are going from H and you're going to the, well, not necessarily the midpoint, but perpendicular to the slope FG. Well, as you can see, the slope FG is a horizontal line, and you're going from -2 to +4, which is an absolute value of 6. So you know you're going to find a line that goes through 3. Okay, so a distance of 3, I should say. So 4 take away 3 is going to give you 1. -2 add 3 is going to give you 1. So you've already got that line. What you've got to do now is work out what the slope is of F and H, and find the perpendicular bisector of that to put it through that point. So you've got to do point slope form, and then eventually you've got to find the slope of GH and perpendicular to that, and put your point through to F. So you've got point slope form again. Okay, so very quickly, let's have a look at question 14. You've got these 3 points. You know that you are going at 3 and -2. Okay, so plot what you've got. So J is 3 and -2, so that's going to be approximately down here. K is 5, 6, which is going to give you over here. And finally, L is 9 and -2, so you're over here somewhere. Okay, and that is L. So again, you've got that. All right, construct your triangle. Again, if you look at JL, you've got a horizontal line here, and you're going from 3, the x-coordinate of 3 here, to an x-coordinate of 9 here. So you know you're going to go a distance of 6. Okay, you want the midpoint, so divide that by 2. That will give you 3. So either 3 add 3, which makes 6, or 9 take away 3, which will also give you 6, and you've got to put that through. Okay, now obviously you've got to find, let's have a look at JK. You've got to find the slope of JK, and don't forget you've got to go perpendicular to that. So you will find the slope of JK, you will do the negative inverse of the slope, and you know it's going to go through that point there, which is 9, -2. So eventually you'll have an equation of that, which will bring it up, and then do